Okay, today we're going to talk about the properties of special parallelograms. Now, we already did a lesson on parallelograms, and let's remember and review quickly about the parallelograms that we learned. First, we learned that if it was a parallelogram, the opposite sides were parallel, the opposite sides were congruent, the opposite angles were congruent, and that the consecutive angles were supplementary. Also, we learned that the diagonals bisected each other. In other words, where the diagonals intersected, that was a midpoint for both segments. So all those things we learned about parallelograms are still holding true. It's kind of like parallelograms are a parent, but there are three children for parallelograms. You have a rectangle, you have the square, and you have the rhombus. And all three of those, they are a parallelogram. They have all the properties that a parallelogram has, but they have things that make them be a rectangle or a square or a rhombus. First, let's talk about rectangles. A rectangle is a parallelogram that has four right angles. Okay, and you can see in the diagram right here that this is a parallelogram. The opposite sides are congruent, the opposite sides are parallel, the opposite angles are congruent because this angle here is opposite to that angle, and that's 90, 90, that's 100, that they're congruent. Those opposite angles are congruent, okay? And then the consecutive angles are the parallelogram rule. 90, 90 is 180, they're supplementary. But what makes a rectangle be more than a parallelogram is that it has four right angles. The other thing that is special about a rectangle is that the diagonals are congruent. Okay, so that takes care of a rectangle. The next shape or special parallelogram is a square. The square has all the qualities that a parallelogram has, and it also has one of the qualities that the rectangle has. It has the four right angles and the diagonals are congruent. But in addition, it has the four congruent sides, which you guys are familiar with, and it also has the four right angles. Okay, and also there's going to be something that we learn about the diagonals of a square. The diagonals of a square are perpendicular. Remember the perpendicular symbol, the upside down T means they're from a right angle. Then you have a rhombus. Now a rhombus, again, it's a parallelogram. Its opposite sides are congruent. Its opposite sides are parallel. All the things that a parallelogram it has. But what makes a rhombus be a rhombus is it has four congruent sides, just like a square, but it doesn't have to have the four right angles. Okay, the other thing that a rhombus does is that the diagonals are also perpendicular. So the diagonals are perpendicular. I'll use a symbol. Okay. And the diagonals do one other thing too. The diagonals are angle bisectors. So you need to, I'm kind of running out of room, but you need to write bisectors. Sorry, I'm running out of room. So the diagonals bisect. In other words, I'm going to draw right above here, my opener, but I'm going to draw a rhombus here to show you what I mean about the diagonals. So here's my rhombus. It has the four congruent sides. Okay. When I draw the diagonals, okay, when they intersect, just like a square, they're perpendicular where they touch, and also they're an angle bisector. So you can see my little blue arcs that I'm marking right here. It's making those angles right there congruent, and also it's an angle bisector here. You see I'm doing the two arcs here. My drawing's kind of small, so it's kind of hard. Okay. So let's talk about some more here. In example 1, it talks about for any rhombus, MNOP, decide whether the statement MO is congruent to NP is always or sometimes true. So first let's go ahead and draw a diagram and figure this out. So we're going to draw a rhombus. And remember, all it has to do to be a rhombus, it has to be a parallelogram and it has to have 4 congruent sides. And so we'll label our sides M, N, O, and P. Okay? And so when we look at this, they're talking about MO being congruent to NP. Well, those are the 2 diagonals, but remember, we didn't say anything about the angles. Okay? The only way that these diagonals will be congruent is if all 4 of the angles are congruent. In other words, this rhombus, for this statement to be true all the time, our rhombus would also have to be a square. And meaning that these angles here were originally right angles, and they're not. So this is a sometimes. Okay. The next question they make is for any rectangle PQRS, decide whether the statement angle PQS is congruent to angle RSQ, always or sometimes. So let's draw a rectangle. Remember, a rectangle, it's a parallelogram. Still opposite sides are congruent, but remember what makes something be a rectangle is that it has 4 right angles. So we're going to go ahead and draw our 4 right angles. Okay, and we need to go ahead and give this thing, label the points. So P, Q, R, and S. So there's our vertices. And they talk about angle PQS. Angle PQS. Notice when they talk about S, to get from P, Q to S, they have to go to a diagonal. So they're talking about this angle here. Is that congruent? I'll go to blue now. All right, let me go to red. Is it congruent to angle RSQ? RSQ. So they're talking about this angle here. Well, remember now, this angle here and that angle there, sorry, that's not a right angle, the black angle. Sorry, I made a mistake. Okay, because this diagonal actually kind of intersects that angle. Okay, are they congruent? Well, let's think about something. Isn't this side here that I'm extending this red line? Actually, let me go to a marker. Isn't this side and this side of the rectangle, aren't they parallel to each other? Well, if that's the case, then this diagonal that's just been drawn, that's a transversal line. And isn't this angle here congruent to that angle there? Because alternate interior angles of parallel lines are congruent. And so this would be an always statement. This is an always. Okay? Alright, so moving on here. I'm talking about the diagonals of the rhombus, and this over here on the right, A, B, C, D. They intersect at point E. Okay, they've given us some angle measures. They tell us that angle BCA is 44 degrees. And that is this angle right here in black that I'm kind of putting a little line. And they tell us some things about AB equaling 9 and AE equaling 7. AB is an outside edge and AE is a part of a diagonal. Well, let's remember some things about a rhombus. If something's a rhombus, it has 4 congruent sides. So doesn't that mean that if AB is 9, then this is 9, this is 9, and this is 9. Next, since a rhombus is a parallelogram, don't the diagonals bisect each other? In other words, isn't point E, isn't that the midpoint? Well, if it's the midpoint, then that has to be 7, right? So that whole diagonal is 14. Okay, Well, so let's answer these questions. The first one, they want to know what is BC. Well, BC, as you can see, is one of the outside edges of the rhombus, which all the outside edges have to be the same. So since AB is 9, then BC is 9. 4, they want us to find the measure of AC. Well, AC is this whole diagonal. Well, remember, we were given that that was 7. We just discovered that that was 7. Why? Because it's a parallelogram, and E is the midpoint bisecting it. So that's how we did that, so we just doubled it. So the whole thing has to be 14. Next, they want us to find angle ADC. So ADC. So they want us to find this whole thing there. Well, remember what I told you about what the diagonals of a rhombus do? Remember, the diagonals bisect an angle. Well, originally they told us that this angle right there is 44. Well, so isn't this side also 44? So this whole angle here is 88 degrees. Well, they want us to find this whole angle here that I'm shading in red. That whole thing. Well, aren't these two angles here consecutive since it's a parallelogram? So if they're consecutive, they're supplementary. Well, they got to add up to 180. So 180 minus 88. And so go ahead and subtract that real quick in your calculator. And that would be, 92. And so angle ADC equals 92 degrees. Okay. So I want you to do problems 6, 7, and 8. I'm going to pause here in just a second, and you can raise your hand and see if you got the 3, 6, 7, and 8 right. But remember some things about a rectangle. A rectangle is a parallelogram, so it has all those properties. In addition, it has 4 right angles, okay, and also the diagonals are congruent. So go ahead and try to do 6, 7, and 8, and then we'll continue on here in a little bit. Okay, so now let's go to this bottom one. We'll work some of it together and some of it on your own. But we have a square now. It says the diagonals of the square LMNP intersect at K, given that MK is half the indicated measure. Okay, so MK is half the indicated measure. Well, they tell you that MK equals 1/2. Again, just remember something about a square. The square has 4 congruent sides. It also has 4 right angles. And the diagonals are perpendicular when they intersect. And the diagonals are congruent. Okay? So, PK, the first thing we want us to find is PK. Well, PK is this other half. Right? PK is the other half. If MK equals 1/2, or 50 cents, well, isn't PK also equal to the same thing? So PK is 1/2. Angle PKN. PKN, I'm going to switch to blue. PKN. So they want us to know this angle here. Well, again, remember in the notes what we talked about. When the diagonals intersect in a square or a rhombus, they're perpendicular. Well, what does perpendicular mean? It means right angles are being formed. So what is this angle right here? What is that angle that I have in blue? What is that going to be if my lines, when they intersect, are perpendicular? That's right. It's going to be a right angle, and it's going to be 90 degrees. Okay? So I'm going to kind of help you out on number 11. They want you to find the measure of angle MNK. MNK. Well, MNK. So they want to know this angle here that I've shaded in red. Well, now remember that thing was originally a 45, that was a 90 degree angle. okay, originally, and then they got bisected. The diagonals bisect in a square and a rhombus. They bisect everything. So I want you to think about what happened to that right angle if it got bisected. Come up with the answer your own. Raise your hand to see if you get it correct. Okay, so we're on our second page. Let's do some more problems. Here at the right, you have this frame and a window. It says you're building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? So to make sure we understand what they're talking about, this right here, this is the opening. So this is the area they're talking about. So with what they've given me, let's look and see what we have. We have this edge is 33 and this edge is 33. And then we have our edge that I'm going to shade in black. This edge is 44 and this edge is 44. And so we have our opposite sides congruent. We're assuming that we have right angles being built. So if we have 4 right angles, we would conclude that it would be. But how do we know that those are right angles? Well, couldn't you draw the diagonals, and wouldn't that make 2 right triangles, right? Well, and then I could draw the other diagonals and make another set of right triangles. And again, for it to be a rectangle, the diagonals have to be congruent. Couldn't you do the Pythagorean Theorem, a squared plus b squared? And if that equals the same thing, it would, but wouldn't it? I mean, think about it. If I go 44 squared plus 33 squared, it's going to equal c squared for the one set of right triangles. And if I do it again and go 44 squared plus 33 squared, okay, won't I get the same thing? Yes, so my diagonals will be congruent, and so, yes, I would have a rectangle in example A. Look at problem B. Okay, we'll do this one together. You measure the diagonals. Now, this is a new problem. This is, you measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? In other words, is the opening a rectangle? No, it's not. Okay, it can't be because, again, remember, for it to be a rectangle, the diagonals would have to be congruent, and the diagonals are not. So, it's not a rectangle. Okay, you guys do number 13 on your own. When you think you have an answer and you've solved the problem and found QS and RT, let me know. Alright, so we have these last 4 problems here. Okay, what is the most specific name for each quadrilateral? Okay, and now remember, I want to remind you, the only thing it takes for something to be a quadrilateral is that it has to have 4 sides. So all these objects that we've been talking about, parallelograms, squares, rectangles, and rhombuses, they are quadrilaterals. It's just that each one of them are more than that. And a square, a rhombus, and a rectangle are all parallelograms. It's just that those 3 things are more than that. So let's look at the first example, number 14. They give us some information, and it's about the diagonals. All they tell us is that these diagonals, you got pieces of them that are congruent. Well, aren't they telling you that the diagonals bisect each other? That's all they're telling you. That's the only information that you are given and told. Well, that means that number 14 is a parallelogram. And that's all it can be. It can't be anything else because there's no any other information. We don't know I mean, I get it that it looks like a square, but we don't know if we have 4 right angles. We don't even know if we have 4 congruent sides. So all we know is it's a parallelogram. Let's look at number 15. Okay. Well, now remember, for a quadrilateral to be a parallelogram, a rectangle, a square, or rhombus, because again, a square, rectangle, and rhombus are a parallelogram, the opposite sides are congruent. Well, these two sides are opposite. Are they congruent? And these two sides are opposite. Are they congruent? No. So it's not even a parallelogram. It's not even in that family. So all number 15 is just a quadrilateral. And that's it. So you guys do number 16 and 17. And when you think you have an answer, go ahead and raise your hand. And I'll tell you if you're right or not. Okay, that's the last of this lesson. Once everybody is finished with the videos, there'll be a couple other things that I will talk about on the board to make sure everybody's cleared up on a couple of questions.